For weeks, the global scientific community existed in a strange state of tension. Not panic. Not excitement. Something deeper. Anticipation. Observatories across Earth had gone silent on one of the most mysterious objects ever detected, an interstellar visitor designated 3I, Atlas. A name that sounded clinical, but concealed something far from ordinary. Telescopes were ready. Scientists were prepared. Models had been built. And yet, no one could see it. The reason? Brutally simple. The sun. The object had moved into a region of the sky where solar glare overwhelmed every Earth-based instrument. Even the most advanced observatories, equipped with cutting-edge optics and decades of refinement, were effectively blinded. The sky, for a brief but critical window, had closed. But not everywhere. The only eye still open. While Earth struggled against light and atmospheric interference, there was one observer that remained untouched by these limitations. Far away, orbiting another world. A silent machine circling Mars. China's Tianwen-1 spacecraft. Positioned in a unique orbital alignment, Tianwen-1 had something no Earth-based system could achieve at that moment: a clear, uninterrupted view into deep space. No atmospheric distortion. No solar interference. No horizon limits. Just darkness and clarity. And in that darkness, it saw everything. The breaking of silence for days, nothing was released. No images. No confirmation. No statements. Only speculation. Why the delay? Because sometimes data doesn't just inform, it unsettles. Then, without warning, the silence broke. China released the first images. And everything changed. First look, something is wrong at first glance. The image didn't seem extraordinary. A distant object. A faint glow. A slightly elongated shape. To the untrained eye, it could pass as just another comet. But scientists don't look, they analyze. And what they saw didn't match expectations. Not even close. The object surrounding Coma, the cloud of gas and dust typically produced by solar heating, was not behaving normally. It wasn't dispersing. It wasn't thinning. It was stabilizing. Even more strangely, it was becoming denser. The pattern no one expected: brightness fluctuations were detected. That, in itself, wasn't unusual. Comets rotate. They release material unevenly. But this was different. The variations followed a consistent rhythm. Predictable. Repeating. Structured. And in astrophysics, structure is everything. Because randomness is expected. Patterns are not. Energy without explanation. Tianwen-1's instruments began recording something even more puzzling. Ultraviolet reflectivity spikes. Sharp increases in energy output. Aligned with rotational timing, but far exceeding expected limits. In simple terms, the object was producing more energy than it should be capable of. For a typical comet, energy output is directly tied to surface exposure and solar heating. But this object behaved like it had an internal source. The moment Earth went blind as 3I, Atlas moved closer to the Sun, Earth's view became completely obstructed. Observatories shut down direct tracking. Data streams went quiet. For the first time in decades, humanity lost sight of a major celestial event. But Tianwen-1 didn't. From Mars' orbit, it continued watching. Recording. Tracking every change. And what it captured during this window would become the most controversial dataset in modern astronomy. The impossible structure. As new images came in, a disturbing detail emerged. Inside the glowing coma, there was shape. Not random density. Not noise. Not artifact. Structure. A dark, consistent region appeared across multiple frames. Aligned. Repeating. Almost engineered. This should not exist in a natural comet. Comets are chaotic. Irregular. Fragmented. This was none of those things. The signal within the noise. What makes this event even more unsettling is not just what was seen, but how it was seen. Because buried inside the data from Tianwen-1 was something subtle. Easy to miss, easy to dismiss. At first. A fluctuation. Not in brightness. Not in motion. But in timing. The pulses recorded from the object didn't just repeat, they aligned. Perfectly. Across multiple observation windows. That level of consistency suggests something very specific in astrophysics: synchronization. And synchronization doesn't happen easily in chaotic systems like comets. It requires stability, control, or design. The limits of current models. To understand why this matters, you have to understand how comets behave. Or rather, how they're supposed to behave. A comet is essentially a loosely bound collection of ice, dust, and rock. As it approaches a star, heat causes volatile materials to sublimate, creating jets of gas and dust that form the coma and tail. This process is uneven, chaotic, unpredictable. No two comets behave exactly the same. But all of them share one trait: they degrade over time. They crack. They fragment. They lose structure. 3I, Atlas didn't. Instead, it maintained coherence. And even more concerning, it appeared to optimize its behavior. Jets became more focused. Energy output became more efficient. Structure became more defined. This isn't just unusual. It challenges the foundation of cometary physics. The data gap that changed everything. When scientists began comparing Tianwen-1's observations with earlier Earth-based data, something critical emerged: a gap. A period of time where no Earth instrument had visibility. And that gap was exactly when the most extreme changes occurred. Think about that. The object entered a blind zone, hidden from Earth's view, and during that time, it increased in brightness, developed structured jets, displayed internal features, produced non-solar energy signatures. Then, when it re-emerged into observable space, it was different. Not drastically, but measurably. As if something had happened while no one was watching. Except, something was. The Mars advantage. From its orbit around Mars, Mars offered a completely different observational geometry. While Earth looked toward the Sun and saw nothing but glare, Tianwen-1 looked sideways. Across the plane of the solar system. And that difference changed everything. Because in astronomy, angle is reality. A slight shift in position can reveal hidden structures, shadowed regions, emission patterns invisible from other perspectives. Mars didn't just see the object. It saw a version of the object Earth could never detect. The possibility of internal dynamics. One of the most debated interpretations of the data revolves around internal activity. Not surface-level sublimation. But something deeper. Something beneath the outer layer. If the object contains internal cavities, chambers, or layered structures, it could theoretically store energy, release it directionally, create controlled emission patterns. This could explain the structured jets, the delayed brightness, increase the anti-solar emission. But even this explanation has limits. Because the energy levels observed still exceed what such a structure could naturally produce. Unless the material itself is different. Not all interstellar objects are the same. Before 3I, Atlas, humanity had already encountered interstellar visitors. Objects like Oumuamua challenged expectations with its unusual acceleration and lack of a visible coma. Then came 2I, Borisov, which behaved more like a traditional comet, but still raised questions about composition and origin. Each new object expands our understanding. But 3I, Atlas, breaks it. Because it doesn't just sit outside known categories. It contradicts them.